Thanks. Thanks, Chantal, for that wonderful insights into data analysis. So, as we mentioned, we're going to do a complete switch. So here, I'm actually going to talk about a product which helps users do very intense data analytics, right? Okay. So first of all, a poll, how many of you here have heard of or used the MySQL open source database? Okay, a lot, and that's what we usually like to hear, because study after study show that it's the most popular open source database, and we feel fortunate that both the paid version, which is the Oracle, the closed source database, Oracle and MySQL, both belong to the same company, and we take a lot of pride in it. These are just some of the customers. If you see across all the board, all different market segments, social, e-commerce, manufacturing, everybody is a MySQL customer, and we are very proud of that. So we all know MySQL has been around forever, very popular, is a great database, but it is optimized for OLTP. Now with data explosions coming, what happens? Now users want to do more deep level analytic operations on a large of data. MySQL was not really geared towards that. So what do we do? Earlier what users did was they would take data out of an OLTP system, maybe do ETL operations onto an external data source, run their analytics outside, and then maybe bring the results back into ETL, resulting in loss of time, money, security, because now data has to move across database systems, right? So about 10 years ago, we started this effort in Oracle and ultimately integrated it with the MySQL, and it's something we called as MySQL HeatWave. So today, the MySQL HeatWave ecosystem is a combination of MySQL and something that we call as a HeatWave engine. As a result, to the end user, there is only one system that they are dealing with. There's only one way to submit queries as before to a MySQL, but now MySQL has been enhanced with the analytics engine. So now you have an OLTP and an OLAP system all integrated into one. And I want to take that a step further. So over the years, we didn't just stop at OLTP and OLAP operations, right? With increasing data, increase for machine learning data in external stores like the lakehouses, we kept enhancing the MySQL HeatWave system. So as a result now, you have one combined source where you can deal with all possible combinations. You can run your OLTP workload, you can run your OLAP workload. If you have data in an object store, in any of the formats, CSV, Parquet, I don't have JSON here, but JSON, Avro, you can bring the data into your MySQL HeatWave system and run queries on it. Furthermore, if you want to do machine learning, if you want to build your models, run inferences on the data, you can still do that as part of the HeatWave ecosystem and with very simple procedures. So I will quickly go over this. There is a lot of information. I'm not sure I can get into the details of it, but we have a booth here, so please feel free to stop by or talk to any of us afterwards. So we'll start off with the MySQL HeatWave. This is just a little level of detailed information that today when we tell customers that you have now this OLAP engine that you can talk to, they worry about what will happen to their applications or their SQL queries which are used to the MySQL interface. So well, we want to assure them that there is no change. Users continue to talk to the MySQL as before. What happens is underneath the covers, we have made a very tight integration with the MySQL optimizer, which can then route the query to the HeatWave engine, which is a very highly scalable distributed engine which runs in the background. The engine optimizes the OLAP queries as needed, returns the results back to MySQL, and the results are portrayed back in the same format that the users are used to. Similarly, if I have data loaded into HeatWave, doesn't mean I cannot do my OLTP. I can continue to do my OLTP as before. and those changes are propagated. So essentially, you continue to get real-time analytics because the moment you do an update, it's propagated to HeatWave, and your analytics are up to date. Okay. So now in the past few years, we already talked about how there is really explosion of data, right? And all of this data today doesn't reside in databases. There are devices emitting signals, and all of this data keeps coming into an object store, what we call is in Oracle terminology, it could be your S3 bucket in some sense, right? Essentially an object store. And now what do I deal with it? If I start trying to ingest these petabytes of data into a MySQL engine, it will choke because my database doesn't have that much power. Besides, I don't want to do that. I want to keep my data as is in my own private bucket. So to address that concern, we introduced this concept of MySQL HeatWave Lakehouse. So it's again a unified query engine. The users are able to query data across your object store and the InnoDB engine, which is the MySQL database. And we have something called a schema inference. So if you have data in, for example, in CSV, Parquet files, you don't know the schema of the data, we provide a feature via our machine learning model that we call as MySQL Autopilot, which automatically derives the schema. And then we scale out. We have, I'll show results, but we are able to scale out today to about 500 terabytes of data. And again, all of this continues to be compliant with SQL syntax. So here, this is just an example of how when you create a table and your data is in the object store, how you would do it. You would point to where your data resides in the object store, and then you can sort of load the data into HeatWave and then query as usual. Once that data is loaded, there is absolutely no difference in how you would interact with the data in the object store. And this is just something we wanted to show. We did some competitive analysis with our competitors, and this was a third party which did all these benchmarks. And as you can see, we were much faster than most of our competitors, and so giving us the best price performance for the buck. Okay. So I already talked about, right, that we have added a lot of these capabilities. But as users deal with more and more data, there are a lot of questions about what is my best schema design. I'm dealing with petabytes of data distributed on a very large cluster. How do I partition my data so that my query perform most optimally? And those are very challenging and very time-consuming tasks for DBAs or end users. So as a result, to tackle some of this, we have an umbrella that we call as MySQL Autopilot. And what it generally does is starting from your entire life cycle, from system startup to loading of data, to querying of data, to failure, it automates as much as possible. And for the things it doesn't automate, it provides very simple interfaces that a user can invoke. And all of this is really backed by machine learning models. And as the data changes, user characteristics change, we continue to evolve those models and keep them updated. And if you have questions on any of these, we can again talk later. Okay. Then I know there's a lot of talk of AI and ML these days, but what does it involve if I want to start using AI, right? So first of all, given a data set, my biggest challenge is there are gazillion of models out there. And if I'm a naive user, a first-time user, how do I know which is the most optimal model for my needs? Even if I pin down on a model, each model really can take in n number of features, right? And how do I decide which are the best optimal features? Even once I decide the features, I need to tune those features. And that is, again, insurmountable task, right? Even suppose I get through all of that, after that, I still need to train a model, and then at runtime really derive some information or infer data from that model. And once after that, I get a prediction out of the model. Now, how do I know? What is my degree of confidence in the model? Because I don't know why the particular model came up with that. I sort of need some kind of explanation or justification as to why did my machine learning model, for example, told me that this picture is of a dog and not a cat, right, for example. So with all these tasks, what we ended doing was we introduced something called as HeatWave Auto ML. And what this does is we have a whole machine learning pipeline inbuilt into the HeatWave data system. It's available at no cost. What it does is there are very few simple APIs that I'll show in the following slide. And based on that, automatically given your task, we do pre-processing or cleanup of the data. We decide algorithm selection, like as to which model is the most useful. We do sampling of your data to make sure we are not taking more data than necessary. We just sample enough data to give you the correct result. We tune your parameters automatically and then give you a result back with explanation as to why the model chose something. So that gives you a high degree of confidence that it actually made sense, whatever was predicted. And all of this, again, as mentioned, is behind the covers. Any data that you're loaded into your lakehouse or the InnoDB table, you can use it, you can run inference on it. So these are just very simple APIs, pretty much with very few parameters to train a model, to explain why you got certain result, to give you a score, and predict even at a row level, very detailed level analysis you can do. And these are pretty much all the 5 APIs that you need to use a machine learning model embedded in the model. And again, these AutoML models today, you can use them for various kind of machine learning tasks, right? For classification, regression, anomaly detection, for recommender system, and even time series estimating. And we continue to add to this as needed. Our time series forecasting and the recommender systems are the most recent ones. Okay. Then I'll wrap up. This is my last slide. And we just wanted to say that with the MySQL HeatWave, we are not just tied to the Oracle Cloud or the OCI infrastructure. We offer this service natively and completely developed by us on AWS. And then the service is also offered in Azure. So we are really optimized for the multi-cloud. And we have numbers, they're available on our website that prove that we are still the best price performance solution. And I guess any questions? Yes, sure.
Yeah, awesome presentation. What's the kind of scaling model for the HeatWave flare? Is it scale horizontally? Is it like a cluster?
Sure, sure. Okay, so yes, HeatWave is, it only runs in the cloud.
Yeah.
There is one particular shape. And the key is today is it's complete in-memory system. So based on how much data you have, it has to scale out. So minimum size is 1 cluster node. And then we go all the way up to 512 nodes.
Okay, so it scales horizontally.
Yes, it scales horizontally. Okay. Yeah, yeah.
Any other questions? Well, Seema, thank you very much.
Yeah.
Mr. and Seema would be happy to talk to any of you, either in this room or over drinks.
Over drinks.